Hello, my name is Mustafa. Welcome to Lab101. And now we will be covering which statistical test to do when you're stuck. So this is the first video of the 5 series. We will be covering chi-squared, t-test, ANOVA, and correlation. Chances are, in natural sciences, you're probably going to do the 4 main groups of these. They have subgroups. I will explain the following in the next videos. So, chi-squared. If you have two independent categorical variables and you have dichotomous data, what does this mean? So you have an independent and another independent, and both are categorical, and your data is either a yes, no, 1, 0 type of question. Dichotomous means there is only two outcomes. So let me explain with the examples. When it rains, this is the first independent categorical. Does it smell good? The smelling is the second independent categorical data. Uh, what do I mean by dichotomous? This shows that it can rain or not. There is only two outcomes. It can rain or not, or it can smell good or bad. There are two outcomes. Uh, let's see this example as well. Those two species of plant do live together. Are living together. This has bad. This has bad grammar. Let's see. Those two species. Do we have two species? Are they living together? So this exists and this doesn't exist. Do you find this symbiotism or parasitism, you find that they're independent? So if you have dichotomous system, yes or no question, exist, doesn't exist, 1, 0, and you have two independent categorical, you should do chi-square test. So watch that video. T-test. What's t-test? Let's see. You have one independent and one. You don't need to have one independent variable, but you can. For goodness sake, if I write one in front of the dependent or the independent, that means you can only have one. So you can only have one dependent and you can have two independent as well for t-test. So in your independent variable, assume that you have one independent variable. You always need to have one at least, but you can have more than that. So in your one independent variable, you have categorical. It has to be categorical, and like that. It should be two groups. If it has 3 or more groups, it's ANOVA. If it has 2 groups, it's t-test. And your dependent variable, and you need to have just one. For t-test, it's numerical. It should be numerical. Let's see the examples and let me explain here. Effects of two different wires on resistance. We have one independent variable to change the difference in wires, independent variable, categorical, and you probably measure resistance with a numerical value through amperes or something like that. You give volts, you measure amperes, you find resistance. Effect, there is a numerical value, one dependent, and you have one independent. It's categorical. Why? One group of one group and another group of wires. Maybe they have different lengths, or they're made of different stuff. When you're working on stuff like this, you should do t-test. And let's see the second example. Temperature change of two materials. So this is a cooling experiment. You have two materials that conduct heat. Maybe it doesn't conduct, but it has to conduct. So you want to maybe preserve it one cotton, and you have another group which is metal or something that has good conductivity, and you measure the temperature change with temperature probe or a thermometer, which is a numerical. One dependent numerical, independent categorical, but it has to have two groups. Let's see another instance. With the ANOVA, you're supposed to do t-test if you have two groups and one dependent numerical variable. You should do ANOVA when see that I didn't write one here, so this means that it can have multiple dependent variables, it can have multiple independent variables, but but those are named different. I will explain in the ANOVA video. Let's see. If you have, it's almost same with the t-test. You have dependent and independent, that is categorical and numerical. Independent is categorical, like Ttest, and dependent is numerical. The difference is you have 3 or more groups. If you have 3 or more groups, you should do ANOVA. Let's see, temperature change of 4 materials. So it's like this one, temperature change of 2 materials, but you have 4 instead. Effects of 5 different wires on resistance. So it's like this one, effects of 2 different wires, but you have more than 2, so you should do ANOVA test. So you should watch the video about ANOVA. And let's see correlation. You have one independent and one dependent variable. You cannot change that. You cannot have 2. You cannot have 3. This is it. And both are numerical values. Let's see. Rate of change. Rate of change. So it's numerical. You subtract one number from another when concentration decreased. So concentration. You have numbers and you're changing probably 0 0.9, 0 0.8, 0 0.7, 0 0.6, and this is numerical as well, so both numerical. This is dependent, this is independent, and you should do correlation here, Pearson correlation probably. If the assumptions are not met, you do Spearman correlation. Change of pressure when volume increases. When pressure increases, no, change of pressure. Oh, we're changing volume instead. So if you increase volume, you'll decrease pressure. So negative correlation. So you should do a correlation here. It would give negative correlation because volume is measured with numerical values. Pressure is measured with numerical values. So you have numerical. Hours heated, and yield produced. So hours heated will be your dependent variable, and the no. It would be your independent variable, and this will be your dependent variable, the yield produced. So if you increase this one, this will increase as well. So you would expect a positive correlation. I will explain it thoroughly in my correlation video, and you should watch that if you're doing this type of experiment. So I explain each test, decide on which one to do, and watch that video. Thank you for listening.